permit me to skip some of my slides because there are a lot.
No, that's really
Yeah, that's up to you. Well, I'm going to talk about the effect of extrusion cooking and simulated in vitro gastrointestinal digestion on pro-anthocyanidins in type 2 and type 3 tannin sorghum. The topic looks a little, what do you think there looks like? An elephant, but we'll try and break it down to that of an ant. The pro-anthocyanidins are basically condensed tannins. And then extrusion cooking is a technique that they use to produce snacks like these cornflakes, this ready-to-eat food, like the baby food that they mix with water. So they use extrusion cooking, and then these ones are very large phenolic compound called pro-anthocyanidins. So my outline before this, where I'll have my introduction of getting better results and then a summary finding. Now I'm going to talk about what I said sorghum is also a drought tolerant crop, and then we all know that it is used in brewing. It's also used in preparing porridges. But this sorghum is classified into three: type 1, type 2, and type 3. And people prefer the type 1 because it does not contain these tannins. Because with the tannins, when you are using it in brewing, they affect brewing. So people prefer tannins. But the danger is that bird eats this one. So anytime that they are going type 1, they go 2 and 3 to protect the birds from eating. They are called bird-proof. So these 2 and 3. Now these tannins in the sorghum are the condensed type, meaning that they are very big. So if you want to use the tannin to produce a ready-to-eat food for children and then for adults, then we are saying that what is its benefit? So, but the tannin itself is anti-nutritional. It means that it has both, it has a negative effect. And one of the negative effects is that it forms an insoluble complex with protein. So it means that when you eat food that contains tannins, it's going to bind with protein, and then you reduce the protein digestibility. You're not going to get the full protein in there. It also binds with minerals, and then you're not going to get the minerals in the body. But the most interesting aspect of the tannins is that it has antioxidant properties. And in our systems, free radicals are produced now and then. So these free radicals, when they overpower the antioxidant system in our body, then we call something oxidative stress. So we call that imbalance in the system. When that imbalance happens, I will show you in my sample what really happened to the target sites. So now because these tannins are very high, because these tannins are very large molecular weight, and we want to eat them, how can we make them bioaccessible so that we can have health promoting properties? So the question is, how can the bioaccessibility of condensed tannin be improved? So this gentleman here was trying to find out what really happened when it's in there. And it has been hypothesized, as I said in my earlier speech, that extrusion cooking can break them down. So this is just the higher molecular weight. So when you use extrusion cooking, you break the polymer into the oligomer, and then to the dimer, and then to the monomer. So we are saying that we want to try to see whether we can break this one up so that the body can take this one, because the smaller the weight, the higher the intake. Because with these, they will go to the backside, and then it can cure certain diseases which are associated with the colon. But we want it to enter into the system. So the objective is to determine the condensed tannin nitrogen properties, and also to determine the bioaccessibility of the condensed tannins. So this is a summary of the whole thing that I said. It's just like you have the two types, you mill into flour, and then you extrude, and then I also prepared a conventional one. So I'm using extrusion cooking, and I'm using the one that we use at home, where you have the powder, and then you form it into like a porridge to eat. and then to eat. And then I built into a powder. And then with the powder, I did a simulated in vitro digestion. And then to see whether what I did was scavenge these free radicals. And these free radicals, wherever they find themselves, will result in all these diseases. They are not visible. You can see that in the multi-organ, it can cause cancer, it can cause aging, that is the NCDs, non-communicable diseases. So this is some of the results that I obtained. You can find out that extrusion cooking has strictly effect on the tannin content because we're looking at the condensed tannins. The tannin content, there was a reduction in the tannin content for both types when you compare it to the unprocessed one. And then extrusion cooking, when I did the radical scavenging, it was also lower than the unprocessed one. Now, I used an HPLC to determine, but the only standard that I have at that time was the monomer and then the dimer. And then I categorized these regions into monomer, dimer, and oligomer. I could not identify the polymer, being that my method was not too selective enough to bring the polymer out. So this is just the relative proportions of what I did in the sample to see that whether it broke down. So you can see that the blue is the monomer and the dimer, and when I did the extruded sample at different feed moisture, the 2 liters means that I added some water content to the sorghum to see how they will fare, and then which one will be suitable when I compare it with the conventionally cooked. And you can see that more of them were produced, the dimer and monomers were produced than the green, which is the oligomer for both sorghum types. It means that the extrusion is having an effect. So this one is just the same thing by looking at the tannin content, and you can see that with the tannin content, more of the monomers are also produced. It means that it's still having an effect. So when I did the digestion, I wanted to find out where will these monomers and dimers be. So this one is an undigested porridge where I put the porridge in water. And then I determined after filtration, centrifugation and filtration, I determined whether we have the monomer and the dimers and the oligomers, which is more than 3 in there. And you can see that with the extruded sample, there were more monomers and dimers for undigested, but with a little oligomer. So the question now is, where did they go? I now did it on the residue, which was left, and I realized that the oligomers were there. It means that it means that more of them were in the residue, and more of them will be in the filtrate. Because the bioaccessibility for the digestion, we are looking at the filtrate and not the residue, because the residue will just pass out. So in the gastric digestion, we found more monomers and dimers in the extruded when we compare it with the conventionally cooked one for type 2 and also for type 3. And in the duodenal, we could see that more oligomers were also coming up. This could be as a result of the enzyme that I used, because in the gastric I used a pepsin enzyme. So the pepsin were able to break down the proteins and release these smaller weight proanthocyanidins. And in the gastric, we also added another enzyme. So that is why these values were higher than the ones in here. So if they are there, so I will skip this one because this one was telling me about how many we were able to categorize these oligomers into. So I was able to do it up to 6. So this is a table for the bioaccessibility from the previous one that I showed, this one. Because here I compared the cooked with the cooked digest, extruded, undigested, and the digest. And based on these, I came out with the percentage of the bioaccessibility of protein. Bear in mind, bioaccessibility is not bioavailability. Bioaccessibility means the amount of the food molecule that will be released into the system, different from which one will be absorbed by the system. So when it's absorbed and is excreted, we're looking at the bioavailability. But we're looking at the thing can be bioaccessible, but it's possible it may not be bioavailable. So you can see that for the extrudate, for both type 2 and type 3, they were all higher than the one that I used my hand to cook for both monomer and dimer. And you see that there were some also oligomeric regions which are also bioaccessible. But the question, as we already said, people have also postulated that the higher ones will not be, but they could be bioaccessible but not bioavailable. So we are saying that if this one will have a higher number or percentage, then it is possible that they will be bioavailable. So after this, I tested these ones with radical scavenging. I did normal in vitro, and then I did a cellular one to see whether they would compare. So I used the ABTS, which is a very long name, and then the oxygen radical absorption capacity to test. And in all these, we found out that the duodenal content keep on increasing from here before the gastric and then the undigested, meaning that the enzymes are playing a particular role in breaking down these big molecules into smaller molecules. And secondly, the extrusion cooking that I used, because of the high shear, was able to also to break down these bigger molecules into smaller molecules. So I then took a CACO2 cells, which is the CACO2 cells, and I tested for cell viability, whether they're going to kill the cells or the cells will be alive. So to mimic what the intestinal linings will be like, so that when you eat, will this have the effect on the intestinal lining or it's blocking? So when you see that from all these, the sample that I added with the negative control, the conventionally cooked, and then the extrusion cooking, they were all viable. It means that the cells were intact. Then I tested it again by adding what we call the positive control. I added an oxidant called the AAPH. It's also another very big long name. So I added them. So the positive oxidant means that it's going to eventually kill the cells. So the negative means that it does not control an AAP, which is the oxidant. Then I added my sample to the positive oxidant to see whether they can regenerate the cells or the cells will be viable. And you can see that I did a 20-time dilution and a 10-time dilution. With the 10-time dilution, there were no significant difference in all the ones that I added. So now I said, no, what is the point of doing 10 times dilution? Let me further dilute my sample to see whether they have effect. And if in 20 times dilution, they still have effect, it means my sample is good to protect the intestinal lining, which is the CACO2 cells. Then I went further to do a DNA to see whether they would just break the DNA cells from the cellular to the supercoiled one. So the one is the DNA without the oxidants. The two is the DNA with the oxidants. And these are the sodium, the three is the unprocessed, the gastric, and digest, just as it is. And you will see from each type 2 and 3, that the AAPH is able to break these DNA cells. So when I added my samples to the DNA, there is some sort of a recovery, meaning that eating whole grain sorghum or extruded sorghum prepared with proanthocyanidins has an effect to repair your system when there is an oxidative stress for both types. But this, you will see that there are some also white bands, which I know the question will come up. But you know, when you buy a live cells, not all of them are viable, some will be dead. So definitely the white lines indicating some of the dead cells that were there. So in conclusion, we say that extrusion was able to break down these big molecules that we're talking about into smaller units. And all is due to the prevailing condition, which is the high shear that I use, a temperature of 150 that I use, which are able to break down. And also the presence of these enzymes that were there in the system to also further break down these larger molecular weight into smaller units. And then we say that the gastric intestinal digestion also simply confirmed that more of the monomers and dimers were there, indicating, and they also protected against CACO2 cells, and they inhibit the plasmid DNA from induced oxidative damage. And in all, we can say that when you eat tannin sorghum, a product that contains tannin, irrespective of it being having the negative effect, when you eat tannin sorghum, it has the potential to protect your system because of its antioxidant properties. So in most products, we can say that let's form what we call a composite product. When you don't want to eat the tannin alone, you can add the tannin to other products, which people have come out with more work, like adding tannin to cowpea, because with tannin is you don't have the essential amino acids, some of them, where with cowpea there is an essential amino, some of them, which is not also in tannin. So in combination, I'm not looking at the amino profiling. So in combination, you will have these two, so that when you break these tannins down, they will not be able to chelate these proteins and make them available, because the smaller ones, they can't bind more strongly than the bigger ones, which binds and become very difficult for them to break down. So in conclusion, we say that eat more tannins, so a whole grain tannin supplement, and your life will better. It will increase your aging and it prevent more NCDs, non-communicable diseases. Thank you very much.